person can reduce the pressure in their lungs to negative 53.0 millimeters of mercury gauge pressure. Calculate the max height of straw the person could use to drink a glass of water. For this problem, I've drawn a tube that is sitting in a glass filled with mercury, and the mercury has gone up the tube 53 millimeters, which is shown on the gauge. What we're wanting to do is pretty much just change out the mercury here into water, because we have the same amount of pressure, negative 53.0 millimeters of mercury, and that's what the person is sucking with, and all we're doing is changing mercury into water. So in this case, we don't need to know anything about atmospheric pressure, which I think is what most people are getting hung up on. Now there's two ways of doing this. What I'm going to do today in this video is show you the difficult way of doing it. It's not really difficult, it's just complex. There is a much easier way of doing it, and I'm hoping you can figure it out on your own. However, if you can't, I might make a video on how to solve it. The numbers do come out slightly different at the end, however, that's just due to rounding errors. So, coming back to this question. Firstly, what do we know? Really, the only thing we know here is the gauge pressure of negative 53 millimeters of mercury. Cool, my pen's running out. Pressure gauge equals negative 53.0 millimeters of mercury. Now I don't like these units, so what I'm going to do is change that into kilopascals. I've looked up on Google, and Google says that to get from millimeters of mercury to kilopascals, you could use pascals as well, but we use kilopascals because that's the usual unit that I work in. So we have 760 millimeters of mercury equals 101.325 kilopascals. So using this information, I can change this gauge pressure from negative 53.0 millimeters of mercury into some amount of kilopascals. To do that, well, I want the units on both sides to be the same. I want to get rid of this. So to do that, because we're multiplying by something, I'm going to divide by millimeters of mercury. On the top, I want kilopascals. That means that this cancels with this, and the units match. This here, we just found out the ratio, 760 millimeters of mercury for 10325 kilopascals. Bring in the calculator. We see that negative 53 times 101.325 divided by 760 gives us negative 7.066085526 kilopascals. Now, if you don't like kilopascals, it's a really easy conversion. We go the same number, but kilo means literally times 10 to the 3 pascals. So we have here a pressure. Now this is the pressure that a person can exert using their lungs, or can reduce their lungs to. So that, in other words, is the amount that they can suck, the pressure that they can suck up the straw. Now we want to change this from pascals. It was in millimeters of mercury, but we want to change this into a height of water. So centimeters of water or meters of water, something like that. To do that, we come back to the good old equation P equals rho g h. What we're trying to find out here is h. So before I do any calculations or put in any numbers, I'm going to rearrange this formula. To solve this formula for h, we want to divide both sides by rho g. That cancels that from that, and we're left with H equals pressure over density times gravity. Now, we know what gravity is. Gravity is 9.81 or 9.8. Pressure, we've just found out in pascals. And density, going to Google again. Now this, what we want is the height of water, so we need the density of water. Density of water, according to Google is 1 gram per cubic centimeter. To change that into kilograms per cubic meter, because we want SI units, I'm going to times it by, well, let's get rid of the centimeters cubed first. Centimeters cubed on the top, because we can then cancel. Puts meters on the bottom. We know from the labs that there is 1 million centimeters for every 1 meter. So we're now at grams per cubic meter. I want kilograms per cubic meter. So grams go on the bottom so that they can cancel. Kilograms on top. There's 1,000 grams for every 1 kilogram. Cancel, cancel. That leaves us with the equation 1 million divided by 1,000 is just 1,000. Bringing all the units over, that's cancelled, that's cancelled, that's cancelled. Oh, we have a cubic meter on the bottom, a kilogram on the top, and that's cancelled. Kilograms per cubic meter. So we know density. Now what do we do? Well, we have all of these values, so we can find the height of water equals P, which is negative 7.066 pascals, divided by rho, which is 1,000. Rho times gravity. Gravity is negative 9.8 meters per second squared. I forgot to put in the units for the density, so I'll just put it at the end, kilograms per cubic meter. Now remember that gravity is negative because positive direction is upwards and gravity acts downwards, so that's why we have a negative here. Now before I go on, I just want to check out the units here. So the units we have is Pascal divided by all of this stuff. So what's a Pascal? Pascal is the same as a Newton per square meter. What's a Newton? Newton is force equals mass times acceleration, so mass is kilograms, acceleration is meters per square centimeters, per square seconds, sorry. So that's the Newton part, and then we have the meters squared as well. Meter divided by square meter, cancel that, we're just left with kilograms per meter seconds. Putting that all together, we have negative 7.066, and I've made a mistake because I missed out the times 10 to the 3 in here. Times 10 to the 3. Times 10 to the 3 divided by 1,000 times negative 9.8. Units, pascals, is this one here that we just worked out. Kilograms per second squared meter. We have the rest of the units on the bottom. Now, because they're on the bottom in the denominator, that means we can use them, but we have to switch it upside down. So the second squared goes on the top, the meter goes on the bottom, the meters cubed goes on the top, the kilogram goes on the bottom. Doing some cancelling, we have kilograms with kilograms, second squared with second squared, 2 meters, 2 lots of meters, and we have 3 here, so that takes it down to a single meter. So that gives us just meters. We can do some more cancelling now with the numbers, because this times 10 to the 3 just means 1,000 times 1,000. So that can be cancelled with that. And what we're left with is negative 7.066 divided by negative 9.8. The units was meters. Now that is what we expected because we wanted height. Meters is measured in a height, so we're all good. And the answer to that is, we've got this number saved from earlier. Divide that by gravity, which is 9.8, negative 9.8, gives us 0.721 meters, which is 72.1 centimeters of water.